Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to continue to talk about balancing chemical equations and using these vocabulary words at the very bottom for the different types of chemical reactions. So if you didn't watch the first video, I suggest going back and watch the video that shows the basics of writing balanced chemical equations, because this is going to be the second video of that series. So in this video, we're going to start talking about these vocabulary words where we're talking about the types of chemical reactions. The first vocabulary word that we have is this idea of synthesis. And it's kind of like a marriage where two things are coming together and building up. And then after the chemical change takes place, they stay together. The exact opposite of a marriage is kind of like a divorce, or what we call a decomposition reaction. That's where something is together initially, and then when the chemical change takes place, they break down into their individual units. Okay. Single displacement is when we have something like element A come into this compound and it hooks up with the Y, and that's basically going to displace the element B. So A comes in and takes B spot, and it hooks up with Y. So A and Y are together, and it leaves B all by itself. In double displacement, they actually switch places. The A and B are switching places. The A is going to hook up with the Y, and the B is going to come back up here and hook up with the X. These four reactions, these first four, are probably going to be used in every introductory chemistry class. They're very common. The last two here are kind of like specialty reactions, and depending on your teacher, you may or may not have them. But the one that I think most teachers would probably be including next after the first four would be a combustion reaction. And that's where this R is represented by some type of hydrocarbon. Okay, so some type of element that contains carbon and hydrogen. These are going to be your organic molecules, are going to react with oxygen, and they're going to form water and carbon dioxide. And the other one, this is one that I do in class because I like to do this demonstration. So I make my students learn what happens when you stick an alkali metal in water, because there's not many things that will like really react vigorously with water, but the alkali metals are so reactive that they will react with water. So we talk about this chemical reaction where the alkali metal, which is signified by the M, is going to react with water to form the metal hydroxide and hydrogen gas. And what we're going to do is we're going to go through each of these problems in the context of what we learned in the previous video of writing balanced chemical equations. So you're going to see these words of synthesis and decomposition, etc., pop up throughout the lesson. Okay, so let's get right into it. Okay, let's talk about our first problem. And what we're going to do is we're going to talk about the synthesis of lithium oxide. Okay, so once again, the word synthesis means the building up. So on the right-hand side, we're going to have our lithium oxide, and on the left-hand side, we're going to have the elements of lithium oxide. So the first step that I'm going to do is just get the symbols down. So it's lithium and oxygen to make lithium oxide. Now I just have the symbols down because that's our first step. Just get the symbols down, okay? Make sure you understand the chemical reaction. Then we're going to check our compounds to see if they're written correctly. The only compound that we have is lithium oxide. Based on the periodic table, lithium's a +1 and oxygen's a -2. So the way we write this formula for the compound is going to be Li2O, because it's going to take two +1s to cancel out one -2. Next thing we're going to do is we're going to check our elements for being diatomic. Okay, we have elements on the left-hand side. Lithium is not part of the diatomics, but oxygen is. It's part of the 7 diatomics that we have. We have 7 of them. That's going to be nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen are our diatomics. So when they're by themselves in neutral, they get a little 2. Now that we checked our elements for being diatomic, we're going to count the atoms. So right underneath my arrow, I'm going to list the lithium and the oxygen, and I'm going to count how many I have on each side. Got 1 lithium on the right, or on the left, and I have 2 on the right. For the oxygens, I got 2 on the left and only 1 on the right. Our final step is to use coefficients to balance the chemical equation. This is kind of like what we're practicing. So the only place you can put coefficients, okay, is in front of the chemicals. And in order to balance this, I might come over here and place a 2 in front of the lithium. And then down here, I'm going to recount. And now my lithiums are currently balanced. I got 2 on each side. My oxygens aren't balanced, so I'm going to come over here and place a 2. And when I place that 2 here, it is going to mess up the lithiums. The lithiums are now 4, and my oxygens are 2, and that's what I was going for, is to balance the oxygens. But in the process, my lithiums became unbalanced. So I come back over here, and I just cross out that 2 that I once had there. If I want to have 4, I'm going to have to place a 4 right here, and now I'm going to have a balanced chemical equation, okay, with 4 lithiums on both sides and 2 oxygens. So the coefficients are going to be 4, 1, because there's no number, and 2 for this balanced chemical equation. 4, 1, and 2. So that is the synthesis problem. Okay, let's go on to the next problem, which is going to be a decomposition problem. What does decomposition mean? That means it's breaking up. So the compound was initially together, and now it's into its elements. So we're going to write it that way. We're going to have the magnesium oxide together, and it's going to break down into its elements of magnesium and oxygen. Now that I got the symbols down, I check my compounds to see if they're written correctly. Magnesium is a positive 2, oxygen is a negative 2, so this formula is written correctly. These are elements, so I don't have to check to see if their formulas are written correctly, but I do have to check to see if they're diatomic. Magnesium is not one of the diatomics. Oxygen is, so it gets a little 2 here. And now I'm going to count my atoms on both sides. I got 1 magnesium on both sides, 1 oxygen on the left, but 2 on the right. And the only place I can put numbers now are going to be where those underscores are. Okay, remember, we use coefficients to balance equations. We use the subscripts only for our formula writing. So after you're done formula writing, you can no longer use subscripts. You got to use the coefficients. So if I want to get 2 oxygens on the left, I'm going to have to place a 2 here, and that's going to change the magnesiums, which I'm not thrilled about, but it is going to get the oxygens up to 2. Now I need to come to the other side and get the magnesium up to 2 by placing a 2 right here. And now this is a balanced chemical equation of 2, 2, 1 between the magnesium oxide, magnesium, and oxygen. And I have a balanced chemical equation. Next problem is going to be single displacement. So let's take a look at what a single displacement problem would look like. And I'm going to ramp up some of the formulas as well. Remember, single displacement, it's just basically an element displacing another element. So the A is going to hook up with the Y and kick the B out. So A is with the Y and the B is all by itself. That's what single displacement means. And this is going to occur between calcium and silver nitrate. So I have calcium and silver nitrate. And you have to have this memorized in my class. Okay, so nitrate, anything that ends in ATE or ITE is a polyatomic ion. It's not an element, and you have to have those memorized. Okay, so we're going to check our formulas. Silver is a positive 1, nitrate's a negative 1. And when we write our balanced chemical equation for single displacement, this calcium ion, which is typically positive 2 when it's in a compound, is going to displace the other positive ion. Because you can't put 2 positives together, it's always a positive with a negative. So this calcium is going to bump out the silver, and we're going to have calcium nitrate, and that's going to leave silver all by itself. This is the idea of having a single displacement reaction. Okay, now calcium is a positive 2, and nitrate is a negative 1. So the correct formula for this is going to be something that looks like this. And then I'm going to list my elements. I'm going to count them, and I'm going to balance the equation. So we got calcium, silver, nitrogen, and oxygen. And I'm going to count each of them on both sides. I got 1 calcium on both sides. I got 1 silver on both sides. I got 1 nitrogen on the left, but I have 2 on the right. This number here will multiply everything inside the parentheses. 3 oxygens on the left, but 6 oxygens on the right. So the only place I can place numbers right now is where the underscores are. And if you look here, the calciums are balanced, the silvers are balanced, but the nitrogens and oxygens are not. Okay, so I'm going to go ahead and place a 2 here, and that's going to mess up my silver, which I am not happy about, but it's also going to make my nitrogens balance, which I am happy about. 2 times 3 is going to make 6 for the oxygens, and I do like that as well. So the only thing that's not balanced right now is the silver. So I come back over on the silver side, and I place a 2 there, and now I have a balanced chemical equation throughout. Okay, so this is single displacement. Double displacement is next, and I even ramped up the problem even a little bit more. So I have double displacement here, and the reason why I think this one's going to be a little bit more challenging is because some students have a hard time with writing the formula for hydrochloric acid. So let's take a look at what double displacement means. In this case, A and B are switching spots. So A is going to hook up with the Y, and then B is going to hook up with the X. Okay, so let's take a look at how this is going to look like between magnesium hydroxide and hydrochloric acid. So we're going to write our formulas, and this might be the hardest part of doing all of this. Is magnesium hydroxide looks like this because this is a positive 2 and this is a negative 1. So we'll need 2 negative 1s to cancel out the positive 2. And then you have to know how to write acids, okay? So this has a hydro and an ic, and my ride has hydraulics is the mnemonic that we use in the level 4 formula writing. And if you don't know how to do this, I highly suggest going back and watching the level 4 formula writing for acids. But when there's a hydro in the ic, okay, it means it's just the chloride ion, which is just the element of chlorine. Of course, acid means it's with hydrogen, okay? So this is the formula for hydrochloric acid because hydrogen is a positive 1 and a negative 1. So once again, the hydro and the ic is what told me that it was just the chloride. And if that doesn't make sense to you, watch the level 4 formula writing video, okay? Now, this is going to be double displacement, okay? So the magnesium and the hydrogens are going to switch spots. So magnesium is going to no longer be with the hydroxide. It's going to hook up with the chlorine. So it's going to be magnesium chloride, and that's a positive 2 and a negative 1. So the correct formula is going to be MgCl2. Now the same thing that's going to happen. Magnesium and hydrogen are switching spots. So the hydrogen is no longer going to be with the chlorine. The hydrogen is going to be with the hydroxide. And I'm going to put this off to the side. So the hydrogen is going to be with the hydroxide. So some people want to write this as HOH, but in chemistry, we kind of like add the H's together. So this is actually just water. 2 H's and 1 oxygen is simply just H2O. So please write water like we normally do as H2O and not as HOH. All right, now that we have our formulas, we can count our atoms, and the only place that we're going to put coefficients in is where the underscores are. So I got magnesium, I got oxygen and hydrogen and chlorine. And one of the hints that I told you in the last video is when you see these elements show up frequently throughout the problem, balance those last, okay? So let's take a look at how all that's going to look like. Got a magnesium on the left and 1 on the right. The oxygens, there's 2 of them because this multiplies everything inside the parentheses, and we only have 1 on the right. The hydrogens, I'm not so worried about right now. Let's come back to them towards the end. Let's double check our chlorines. We got 1 on the left and we have 2 on the right. So what I'm going to do here is because hydrogen shows up in 3 places, I'm going to worry about the hydrogens at the very end, and I'm going to balance everything else first and then come back to the hydrogens. So my oxygens are not balanced, so I'm going to place a 2 here. That will give me 2 oxygens. As far as the chlorines, they're not balanced. I'm going to place a 2 right here, and that's going to give me 2 chlorines. And now the magnesiums, oxygens, and chlorines are all balanced. I just got to worry about my hydrogens. Let's see if everything works out, okay? I got hydrogen in 2 places. There's 2 right here, plus 2 right here, for a total of 4 hydrogens on the left-hand side. And then 2 times 2 tells me I have 4 hydrogens on the right-hand side. So it just works out. When you balance everything else first, a lot of times that last element will balance itself out. And if I tried to start this problem by balancing the hydrogens, I probably would get, I might not be able to do it. And it might give me a lot of grief, and it might take me a lot of time. So remember, the elements that show up most frequently, make sure you balance those last. Okay, next problem is going to be combustion. Remember, that's when we have a hydrocarbon and it's going to react with the oxygen. So this is kind of like the fuel. And of course, you need oxygen to make the combustion occur. And it makes water and carbon dioxide. So my next problem is going to be with methane. And the formula for methane is CH4. Now, I got that from my organic unit. So if you don't know how I got methane, you can watch the Introduction to Organic Chemistry video for that. So as you can see, this chemistry builds from one video to the other. So if we're in a lesson on balancing chemical equations, and we've talked about some of this other stuff before, then you might have to go back into those videos and kind of get that information. But I try to do a quick review as we come across those issues. Okay, so combustion, once again, I got my methane, and that methane, CH4, is the R, and it's going to react with oxygen and it's going to produce water and carbon dioxide. So it's going to react with oxygen and make water and carbon dioxide. And because we have this format set up already, we pretty much have all our formulas written correctly. The only thing that we had to substitute was the R for methane. So I'm going to count my carbons, hydrogens, and oxygens. And in this problem, oxygen is showing up in 3 places. So I'm going to balance that last. I'm not even going to worry about it until the end. So 1 carbon on both sides. As far as the hydrogens, I got 4 on the left, okay, and 2 on the right. So let's balance those hydrogens and then worry about the oxygens at the end. Okay, so if I want to have 4 on the right, I'm going to place 2 here, and that's going to give me 4 hydrogens. The carbons and hydrogens are balanced. Let's count up the oxygens, okay? I got 2 oxygens right here from that problem, or from that compound, and another 2 oxygens from the carbon dioxide. So I have 4 oxygens on the right-hand side of this problem, okay? Currently, I only have 2 oxygens on the left-hand side. So if I want to have 4, if I place a 2 here, 2 times 2 will give me 4, and then it will be balanced as 1, 4, 4, 1, 4, 4, and I have a balanced chemical equation. So this is the combustion of methane, okay? And I think this one, it's not going to be as popular as the first 4 that we've done, okay? But still, I think there's going to be a lot of instructors and a lot of teachers or professors that will require you to understand kind of like the format of a combustion reaction. So it's always some type of a hydrocarbon reacting with oxygen to form water and carbon dioxide. Our last problem is the alkali metal with water. Okay, now this is something that I do with my students. Don't know if your professor would do this or not, or your teacher. But the alkali metal is very reactive. It will react with even water, and it's going to make the alkali metal hydroxide and hydrogen gas. So let's kind of get that format. Now we're dealing with potassium. So potassium is going to be the M. So K plus H2O will make KOH, which is potassium hydroxide, and hydrogen gas. And we're going to figure everything out. We're going to count up our potassiums, our hydrogens, and our oxygens. And when I analyze this, it looks like the hydrogen is the most frequently used element here. So I'm going to balance that last. Potassiums are 1 on both sides. Okay, the oxygen is 1 on the left-hand side, and it's 1 on the right-hand side. So really, all I have is to balance the hydrogens in this problem. Okay, so I got 2 hydrogens on the left-hand side, and on the right, the hydrogen is in 2 places. Okay, I have 1 right here plus 2 right here for a total of 3. So on the left-hand side, it's always going to be even because I have the 2 right here. So how can I make the right-hand side even? Well, if I place a 2 here, I'm going to make the hydrogens even, but let's see what it messes up first, though. So it messes up my potassiums, which I'm not crazy about. It messes up my oxygens, which I'm not crazy about. And it also messes up my hydrogens. Okay, so instead of having 1 right here, there's now 2 for this compound, and 2 plus these that are over here, so 2 plus 2 is going to make that 4, which makes it even, which I do like. So I can come back over here and make the hydrogen 4 by placing a 2 right here, and that makes the hydrogens balance. Of course, 2 times 1 for the oxygen makes the oxygens balance, so I like that. The hydrogens and the oxygens are balanced. And the last thing I need to do is place a 2 in front of the potassium, and then I believe everything's balanced. 2 potassiums, 4 hydrogens, and 2 oxygens for this particular problem. So I hope all this information has helped you, okay? If you did find this information valuable, I really suggest that you like, subscribe, and please leave a comment because that's the part that really helps the channel grow. And really, I'm just trying to help students and even teachers that are new to chemistry, learn it in a straightforward fashion.